Hi everyone, it's Mr. Chang, and then we're doing Relations and Functions lesson 3. And today we focus on x-intercept and y-intercept. So what is that? Well, it's about a relations. We talked about in last class. Relations is a math concept that connects two quantities together. So it could be time and speed. It could be your age and your height or your weight. Okay, so just relate two things together. And then a relationship can be represented by a set of order pair. Okay, so in the order pair, there are two components. The first one is the x coordinate. The second one is the y coordinate. And then the first one is always the independent variables, right? And then the second one is the dependent variable. Y depend on x. Now, when we look at a graph, the right way to understand them is they show you a relationship between two quantities, the x-axis and y-axis, whatever the label is. And how is it represented? They're represented by every point on the graph. So if you look at this line, well, you should look at them as million points. Okay. Now, not just the point that has a whole number value, it's all the points in between. So you can literally fit million points in there. And why do we say it's a point rather than you should look at the whole graph? Okay, every point is a coordinate x and y. So every point has a value x, one x and one y. So the relationships tell you what's the relationship between the x and y by looking at every point. So same as this parabola, you look at all the points here. Okay, and even a circle, you look at them as points, and then you find out their relationship. Okay, let's look at what the example want to say here. Now, there's million points, all right, so all the points are the same, but not really. Some points are more interesting than the other. They are the x-intercept and y-intercept, okay? So they're just a point, but then we give them a name. All the other points are, sorry, no name. All right, so what are the coordinates of the points where each graph crosses the x-axis? So this is the x-axis here. Maybe I choose a different color. Let me choose blue here. So for graph 3, there are 2 points crossing the x-intercept. This one has 2, this one has 1. That they don't have to be whole number, but for this example, they give you whole numbers to make it easy to understand. All right, so for graph 1, the x-intercept is -3, 0. For graph 2, the x-intercept is -2, 0 and 3, 0. -2, 0 and 3, 0. For this graph is -4 and 4. -4, 0, 4, 0. The order doesn't really matter. All right, what do all these points in common? So look at all these coordinates. What's in common? You would say all the y values are 0. Do you see that? Yes. Okay, so how about the y coordinates? The y-intercept. Okay, so for this graph, the y-intercept here is 5. This one is 6. And then this one is 3. Oh, this is 4 and -4. Okay, so what's in common? You can say all the y equal to 0 for the x-intercept. Now for the y-intercept, we find out is 0, 5, 0, 6, 0, 4, and 0, -4. Okay, once again, the order doesn't matter. Okay, order as in like 0, -4, 0, 4. You can write it this way. What's in common? X equal to 0. Okay, so that's the nature for the x-intercept and y-intercept. Whenever it's an x-intercept crosses x, it means y equal to 0. And whenever y-intercept crosses the y-axis, it means x equals 0. All right, so if we go to the next page, it summarizes it here for you. Okay, for the x-intercept, the y-coordinate is 0. Y-intercept, the x-coordinate is 0. So in order to find out the x-intercept, you just let y be 0. You can find it. And then to find the y-intercept, you set x be 0. Okay, so remember this because this will be useful in higher grade, in grade 11, grade 12, you do the same thing. So given any equation, if I ask you to find the x or y-intercept, you just let the other one be 0, then you can find it. Okay, so let's look at an example. Of course, if you see the graph, you can find it right away. But what if you don't have a graph, or like the graph is too complicated to draw? You can always let x and y be 0 to find out the answer. Okay, so look at this equation. 3y equal to 5x plus 15. Algebraically determine the values of x and y-intercept. All right, to determine x-intercept, remember what we say? We say let y be 0. All right, so look at this equation, and then you let y be 0, and then you solve for x. You find out when y is 0, what will be the value for x? Okay, so this becomes anything times 0 is just 0. All right, move the 15 to the other side, so minus 15. So to work with the equation, whatever you do to one side, you do the same to the other side. And then what you're trying to do here is to isolate the variables. Finally, divide it by 5. And you always write your variable final answer to the left. X equal to negative 15 divided by 5, this is negative 3. Here we go. That's my x-intercept. To write that as a coordinate pair, how does it look like on the graph? Is x, y. Okay, x is negative 3, so you write x negative 3, and y is 0. Now, to find the y-intercept, you let what? Let x be 0. Okay, 3y equal to 5 times 0 plus 15. Okay, 5 times 0 is easy, just disappear, and then divide by 3. Here we go, y is 5. Okay, so that's the answer. The y-intercept is 5. You can also write what's the coordinate of this y-intercept. You write 0, 5. Why is this 0 first? Because it's x, y. So for this graph, there's only one x-intercept and one y-intercept. Now let's look at next example. Okay, graph number 3. And then for that circle, we actually have an equation for a circle. This is an equation of a circle. Okay. And then we know there are two x-axis x-intercept and two y-intercept. Okay. No matter what, you do the same thing. First, you let, for x-intercept, you let y be 0. Okay. X squared plus 0 squared. When I substitute, I always put the brackets there. Okay. So x squared equals 16. All right. The next step is x is plus or minus 4. When you square root a number, make sure you put a plus or minus in front of that. Okay, so this is me x, which means the two x-intercept are 4, 0, xy, and then negative 4, 0, another xy. So this bracket means this is a coordinate pair. This comma just say there's another answer. All right, so this is how you write. And then the y-intercept, you let what be 0? X, y, z. Okay, you let x be 0. Okay, plug this in here. 0 squared plus y squared equals 16. Or you say it's the same thing. Yeah. Sometimes it's just the same thing. Here we go. All right. But when we write the coordinates, be careful because this time this is y. Okay, this is x, x is 0. So you write 0, 4 and 0, negative 4. So this is x and y-intercept of any equation, any function, and you can just find it that way. All right, some application questions. Okay, so here we go. Lisa purchased a new car. The value of the car can be represented by this formula. So you start with 20,000, and every year it minus 1,250. So T is age of the car. So in other words, car depreciates. Okay, over time it gets cheaper and cheaper. So in the 0 year, okay, when you first get it, all right, the output is you plug in 0 to T, and then that's the original price. 2 years later, it reduces by 2,500. 2 times this, all right, so it's 17500. 4 years later times this is 5,000. So the price coming down, and then price coming down. All right, so you just, the order pair are just writing 0 and 2 together. Okay, you get it. And connect the dots with a straight line. So just coming down. So let me scroll down a bit. Oh, it's too big. Okay, anyway, you get the idea. Okay, I'll put the graph there in a minute. All right, so I reduce the size. Now you can see everything. Okay, so I put the graph there. So these are all the dots. All right, so it's depreciate, showing a relationship between the price of a car and its value over time. What does the order pair represent? Here, all right, this point has a name. It's called the y-intercept. What does it represent? It represents the initial value. Usually y-intercept is the initial value of the things you have. Here is the car. Use the graph to estimate the t-intercept. Okay, why is it called t? Okay, because it's not variable x, so it's t-intercept here is it means x-intercept. You extend the line, it's 16 years. What does it represent? It represents 16 years later, your car worth nothing. Very bad. Okay, but you can still drive it. Now D, use the graph to estimate the value of the car after 3 years. Okay, so just from here, just look 3 years. So it's in between 15,017 and 500. So the answer is 16250. All right. After 10 years, 10 years is here, 7500. After 14 years, just 2 years before is worth nothing, 2500. Use a formula to verify it. So you plug in all those numbers into the formula, you get the same thing. Use the graph to estimate. Now the other way around. When is it worth 5,000? So you look here, 5,000, you come down here, 12 years. Okay. Half of the purchase price. So 10,000, half mean 20,000, half mean 10,000. 10,000 cut it through here will be 8 years. Okay. So you just examine the graph. Okay. Sometimes you need to look at the x and then get y. Sometimes you look at the y, you get x. And sometimes, make sure you don't confuse the x and y. That's the whole thing. All right. Now, we're almost done with this unit. Oh, let's finish the fill in the blank here. Complete the following statement to describe the duration. The original value of the car is 20,000. It depreciates in value by 1,250 per year and has no value after 16 years. All right. In this lesson, using algebra determine the exact value of the intercept, whereas using graph can give you estimate for intercept. Well, if it's right on the line is also exact. The last thing I want to say is sometimes intercept is not necessarily a perfect number. It could be a fraction, it could be a decimal. So it doesn't have to be a whole number. All the example we've seen so far is whole numbers to make it easy, but it doesn't have to be. In lesson 5, we will use the features of graphing calculator to determine more accurate results from a graph. So when it's not exact, how can we find it? Well, that's why we have graphic calculator, and you can use it to find the exact answer or approximate answer. Okay, so we also introduced this term. We learned this in younger grade, interpolation. So when you find the answer within a range, extrapolation when you find an answer outside the range. And we are done with lesson 3. So thanks for listening. Hope you enjoy it.